Welcome, dear students. Today we'll be talking about how to solve a simultaneous equation graphically. As long as we're talking about a graph, so we're talking about the XY coordinate plane. Let's start by example 1. In example 1, the question says, find graphically the solution set for these two equations. The first one is x plus y equals 5, where the second one is y minus x equals 1. For these two, we're going to plot points. Here, there's no need to make the table, as the first equation says x plus y equals 5, so I just need to get a value of x plus a value of y that gives me a sum of 5. So you can plot a point like here, 1 and 4, plot another point, 2 and 3, plot a third point, 3 and 2. Connect between them to draw the line. Then, let's go and draw another line that represents the second equation, which is y minus x equals 1. In the second equation, again, there's no need to make the table of values because I need to get any two numbers that their difference is 1. So in here, for example, I would choose y2, that x will be 1, excellent. So it's 1 and 2. The second one, if I put y equals 3, then x is 2. So it's 2 and 3. The third one is 5 for y, then 4 for x, so it's 4 and 5. If you connect between them, then the solution set will be the meeting point or the intersection point between these two lines. As you can see it here, the two lines are intersecting at point 2 and 3. Then the solution set for these two equations is 2 and 3. The question is asking you to find the solution set of these two equations, again graphically. The first equation is y minus 2x equals 5, where the second equation is y plus x equals 2. Then, let's start by the first equation. Y equals 5 plus 2x. So the first equation, it was y minus 2x equals 5. I solve for y, so I move the 2x to the other side. So the equation becomes y equals 5 plus 2x. Then let's make the table of values. We put x equals negative 2, negative 1, and 0. And I find the y values. So for the first one, if I put x equals negative 2, the y will be 1. If I put x equals negative 1, the answer, which is y, will be 3. If I put x equals 0, the answer, which is y, will be 5. Then go and plot these points on the graph. The negative 2, 1, the negative 1, 3, and the 0, 5. You will form 3 points, connect between them to form the line. The second equation is y plus x equals 2. Then, if you move the x to the other side, y equals 2 minus x. Let's make the table of values. We'll see that if you put x equals negative 1, the y will be equal to 3, because 2 minus negative 1 is equal to 3. If you put x equals 0, then y equals 2. If you put x equal 1, then y is equal to 1. If you plot the 3 points on the graph, here's the first point, negative 1 and 3. After that, the second point, 0, 2. After that, the third point, which is 1, 1. If I connect between these 3 points, it will form another line. Then, the solution set is the intersection point of these two lines. As you can see here on the graph, what is the intersection point? Yes, exactly. It's negative 1 and 3. So the solution set is negative 1 and 3. It's 1 point. Its coordinate is negative 1 for x, and y is 3. Before we go to example 3, let's remember very well that the solution set or the solution of the two equations is the meeting point between the two lines that you are going to graph. The solution is the meeting point of the two lines. Let's go now to example 3. The two equations that we have in example 3, the first one is y plus 2x equals 5, or the second one is 2x plus y equals 7. So, if we start by the first equation, and I solve for y, so y equals 5 minus 2x. Let's do the table of values. If I put x equals 1, then y equals 3. If I put x equals 2, then y equals 1. If I put x equals 3, then y equals negative 1. Let's go and plot the points on the graph. 1, 3, 2, 1, and 3, negative 1. Let's connect between them to form this line. Let's start. Let's go now to the second equation. If I have 2x plus y equals 7, I move the 2x to the other side. So y equals 7 minus 2x. Let's go to the table of values. Put x equal 2, then y will be equal 3. Put x equal 3, then y will be 1. Put x equal 4, then y will be negative 1. Let's plot these points on the graph. So 2, 3, 3, 1, and 4, negative 1. If I connect between the 3 points, it will form another line. As you can see now on the screen that the red line and the blue line are two parallel lines. So if they're two parallel lines, do they have any intersection points? Definitely no. As long as the two parallel lines have no intersection points, and we said that the solution set is the intersection point between the two lines, then here we have no solution. The system of these two equations have no solution. So here the solution set is phi. If the two lines are parallel, that means that the two lines are not going to intersect. As long as they're not going to intersect, so we have no solution set. As long as we have no solution set, then the solution set is phi. Let's go now to example number 4. In example number 4, the question is asking you to find the solution set of these two equations graphically. The first equation we have is y plus 2x equal 5, where the second equation is 2y plus 4x equal 10. As we usually do, we start by the first equation and we make it as y equals. So y equals 5 minus 2x. Let's go and do the table of values. If I put x equal 1, then y equal 3. If I put x equal 2, then y equal 1. If I put x equal 3, then y equal negative 1. If I plot them on the graph, here is 1 and 3, 2, 1, 3, negative 1. I have 3 points. I connect between them to form the first line. Now let's move to the second equation. In the second equation, 2y plus 4x equal 10. So we want to put y alone in one side, so we move the 4x to the other side. So 2y equal 10 minus 4x. If I make the table of values, if I put x equals 0, then y will be 5. If I put x equal 1, then y will be 3. If I put x equal 4, then y will be equal to negative 3. If I plot the points on the graph, 0, 5, 1, 3, and 4, negative 3. As you can see, that the new 3 points are exactly on the red line. So this means that the blue line will be identically the same. Then we'll see that the blue line is identically the same with the red line. Then the two lines, if they are exactly on each other, we call them two coinciding lines. Okay, we said before that the solution is the meeting point or the intersection point between the two lines. As you can see here, the two lines are intersecting at many points. This means what? The two lines have infinite number of meeting points. Then the two lines have infinite number of solutions. The two lines are coinciding, then this means that these two equations have infinite number of common solutions. In this situation, we consider the rule which determines the number of common solutions of two simultaneous equations. If I have ax plus by equals c, and the other one is ax plus by equals c, so here we're making it as a1x plus b1y equals c1, and a2x plus b2y equals c2. Then, if you see that a1 over a2 is equal to b1 over b2 is equal to c1 over c2, then these two lines are coinciding together. Then the two equations have infinite number of solutions. For the second one, if a1 over a2 is equal to b1 over b2, where they're not equal to c1 over c2, then these two lines are two parallel lines. Then they're not going to meet together. Then here we have no common solution, or we have the solution set is phi. The third case, that a1 over a2 is not equal to b1 over b2 is not equal to c1 over c2. Let's move to another example, which is a word problem. In the word problem, it says, Abdullah bought a pen and 2 notebooks for £17. If the price of the pen is £2 more than the notebook price, find the price of each of the pen and the notebook. So, as we always start by putting a label, so we're going to let the price of the pen labeled by X and the price of the notebook labeled by Y. Let's now write the two equations. In the first equation, a pen and 2 notebooks equals 17. So, X plus 2Y equals 17. And for the second equation, the price of the pen is £2 more than the notebook. So, the difference between them is £2. So, X minus Y equal 2. Let's now graph the two lines. By the table of values, you will see that the meeting point between these two lines is 7 and 5. So this means that X equals 7, where Y equals 5. And we know that the X is representing the pen price, and the 5, which is the Y, is representing the notebook price. So here, the price of the pen is £7, where the price of the notebook is £5. And now, dear students, we have finished explaining how to solve a simultaneous equations graphically. And for you to assess your understanding, you need to solve the coming questions that you will see on the screen now. Thank you very much, and see you next session.